Ice cores taken 2,000 meters below the surface have enabled us to look at the last 160,000 years.
This is probably a year or so, perhaps 2 years of snow accumulation. Yes, this is the top end, it's here, so this is the youngest snow, and the bottom we have the oldest snow.
There's no doubt from the record that for the last couple of 100,000 years, temperature and carbon dioxide levels do appear to follow each other. But it's far from clear that carbon dioxide causes temperature to change.
We certainly know that the temperature falls long before the carbon dioxide levels fall.
Is it thought that the decline in temperature actually causes a decline in CO2?
Well, it clearly does. I mean, it clearly, in the end, that the sources of CO2 are reduced and the sinks for CO2 are increased. So there has to be this quite straightforward effect.
So, if the record from the distant past tells us that, if anything, it's temperature that causes CO2 to change and not the other way around, what does the recent past tell us? One matter over which there is no dispute is that levels of carbon dioxide in the atmosphere have increased substantially. But it's not been a steady increase. CO2 levels rose slowly from the middle of the last century, but it was only in the 1950s that levels started to increase rapidly. But even if we accept the thermometer data, the temperature change, which is supposed to have been caused by CO2, does not coincide with the increases in carbon dioxide.
It's pretty apparent that the lion's share of the warming occurred before the lion's share of the trace gases went in.
Yes, in fact, that's a remarkable puzzle.
So how does he solve it?
In the first part of the century, you see a large natural warming. Well, you know, natural variability's got to go both ways, so why should it be strange that in the next 40 years or so there was a large natural cooling, which was large enough to offset the greenhouse effect?
Michaels has a more straightforward explanation.
There are only so many things that can go against a simplistic theory before you have to admit that the theory is simplistic and needs revision.
So, not only does the climate record fail to prove that carbon dioxide causes temperature change, but if anything, there's evidence to the contrary. The second pillar supporting the greenhouse effect turns out to be as insubstantial as the first. The third pillar supporting the greenhouse effect is the climate models. Perhaps more than anything else, it's been the predictions of these climate models that a doubling in CO2 will lead to an increase in global temperature of 3 to 5 degrees Celsius by the end of the next century that have sustained fears of an impending crisis. But can we rely on these predictions? Although superficially similar, the climate models are radically different in character from the models used to provide daily weather forecasts. The computer models used to generate the weather forecasts, with which we're all familiar, start from information about the current situation and try to calculate what will be happening over the next few hours and days. The complexity of the mathematics involved means that the models cannot predict with any accuracy beyond 5 days. Changes in climate take place over decades and centuries, so these weather forecasting models are of no use for estimating climate change. Instead, the climate models do not start from the current weather at all, but try to simulate the entire climate of the Earth from first principles. The computer is given the amount of heat arriving from the sun, the laws of physics which describe how heat radiates, and the radiation properties of the atmosphere. It then calculates the temperature of the Earth, the wind speeds, the rainfall, and so forth. The models then simulate the Earth's climate over a number of years and produce an average annual temperature cycle. We can see how the predicted temperature in a single year differs from this long-term average. The red areas are hotter than normal, and the blue areas cooler. But according to the models, with a doubling of CO2, large areas become hotter than the current average. This model, produced by Steve Schneider's department at the US National Center for Atmospheric Research, is one of the world's 5 influential climate models. But if we're to believe the predictions of these models, we must first be convinced that they accurately simulate our current climate.
The point that should be made is that
Dr. Mitchell heads the team at the Met Office in Britain that has developed another of the world's major climate models.
what in general we get is not just the north-south distribution of temperature, but also the large-scale variation across the continents. And this is very much as observed.
They do very well. When we take our models and we let the sun get higher, it gets warmer, and we let the sun go away, it gets colder. I remember once talking to a U.S. congressional hearing about this, and one of the senators said to me, "You mean to tell me you guys have spent $1 billion of our money telling us that the winter is cold and the summer is hot?" And my answer was, "Yes, sir, and we're very proud of that."
Some scientists, however, are less impressed.
I don't think we could speak of the models as being accurate at this point. They're experimental tools. We're trying to forge these tools. To use them in a forecast mode for delicate things like this warming is calling on an accuracy these models simply do not have.
We certainly don't understand the models well enough to take their predictions seriously.
One criticism of the models has been that they fail to take account of all the so-called feedback effects. Some of the most important of these are related to clouds. Professor Jonas is a world expert on the effect of clouds on climate. His experiments are designed to find out how different types of cloud reflect the sun's rays.
The climate models are treating clouds in a very simplistic manner, and this makes it very difficult to include the true magnitude of the feedback effects within those models.
If temperature rises, evaporation increases and more clouds are created. But in turn, the clouds then reflect the sun's radiation away.
This has the effect of giving rise to a smaller amount of warming at the Earth's surface.